Good morning, friends. This is Desian, Assistant Professor, King's College of Engineering, Department of Mechanical Engineering. Um, in Computer Aided Design and Manufacturing, Unit 2, Geometric Modeling. Today we are going to see the topic is beizers curve. Already we uh, briefly discussed about the B-spline curves. The following with the B-spline curves, we go for a beizers curves. The bezier curve is another type of curve to define a geometry or define a splines in computer aided design and manufacturing, especially in CAD software. The bezier curve plays the major role. This is the second unit syllabus. In this syllabus, the uh, major syllabus is deals with curves and splines and patches. Other than that, the cone, BREP, CSG and also available. Especially the B-spline curves, beizers curves and the Hermite curves. These are all some important topics in Unit 2. So after the completion of Unit 2, after studying the Unit 2, what are all the objectives, what are all we are going to gain, what are all the knowledge you gained in Unit 2. First one, introduction to bezier curves and surface. What is bezier surface and what is bezier curve? You have the detailed knowledge. Second one, how to derive the matrix format of B splines and bezier curves. And third one, what is standard cubic bezier? These are all the things we have to know in this unit after the completion of second unit. So just listen. What is Beizer's idea? Based on the Beizer's idea, the B-spline and the bezier curves and bezier surface are developed. So just before going to the bezier curve, we have to know what is the basic Beizer's idea. In graphics and computer aided designing, we have already every time we are using the derivative data, especially the second derivative. Already we explained there is a equation f of x is equal to 2x square. The first derivative of 2x square is 4x and second derivative of 4x is 4. So the data we are using is always second derivative. When the three-dimensional equation consists of more than 3 parameters, we have to go for a Beizer's Hayes-Mitter's curve. So the Beizers is having the idea, he suggested the 4 data points with the cubic interpolating curve. He is having 4 data point P1, P2, P3 and P4, and it is derived from the Hermite form. When the form is Hermite, we have the exponential notation more than 4. We have to reduce for 2 derivative and then we use it in the Beizer's curve. This is the basic idea about the Beizer's curve and Beizer's surface. So this is the approximate derivatives how the Beizer's curve is happen. There is a point P1 and P0, P2 and P3, P0, P1, P2, P3. In B-spline curves, any type of curve is defined by the B-spline surface which is surrounded by 9 quadrants. Likewise, the same technique is followed here but in the reverse manner. In B-spline curves, there is a kinematic arrangement is there. Therefore, P0, P1 are plotted in horizontal and P2, P3 are plotted in another horizontal. We have to draw it and we have a rectangle trapezium-like structure to define any curve. But in Beizer's curve, the reverse of that is done. P0 and P1 are in vertical and P2 and P3 are in vertical. So we can easily identify the universal slope. The universal slope is a very important parameter for defining any type of curve. So in this basis curve, we can easily find the value of u. So the equation for the interpolation, from the starting point we have one constant, that is c0. In the first point we have four derivative, because the finishing line is p1, so we have four derivatives, c0, c1, c2 and c3. We can take it as constant or derivative. How the constant and derivative are almost same means, after the first derivation, differentiation and second derivation, any type of equation we can convert it into constant. So only we put c0, c1, c2 and c3. Then p0 dash and p1 dash, this is integration. When the derivation is nothing but differentiation, and when we put dash means we have to integrate. So likewise the same thing is followed and the linear solution for C is solved. So basis matrix can be formed based on this equation: p suffix p bracket u is equal to ut into m suffix b into p, that is equal to b into bracket of u the whole power t into p. P is nothing but a point, u is the universal function, ut that is u transverse, and mb that is matrix for base function, and p is the point function. Again the b is nothing but basis surface matrix into u transpose, and it is multiplied by p. These are all on the b is nothing but bending function, blending function or basis function. Then we go for the for every basis curve and basis surface we go for a Bernstein polynomial, that is nothing but the values given in the equation from 0 to 1 based on the blending Bernstein polynomial. So some special cases and a function we go for an infinity or a negative value, but especially in Bernstein blending polynomial, all zeros are available from 0 and 1. For any degree it is sum to 1. For any degree it is sum to 1. They are all between 0 to 1. They are all available in between 0 to 1. Especially some special curves it is infinity or it comes under the negative value. Okay, next, convex hull property. This is very important. There is two properties of a mirror, convex and concave. Convex means the surface will be bulged somewhat, positive loop of the sinusoidal curve when we are view from the rear. So in basis curve, look at the basis hull curve given in the diagram. P0, P1, P2 and P3, it can be reunited by means of a convex hull. There is a convex point is there. When the basis curve is convex, then only it is applicable for the further matrix progression. When the convex hull property is not applicable in any basis curve, it cannot be used. So next we call it as basis patches. Basis patches is almost as same that of the B-spline patches. A single patch is surrounded by 9 patches. From any of the interpolation can be easily done by using this basis patches form. So with the help of basis patches and basis line, we have come to the analysis that how we can do better in basis surface. The first one, the derivative of continuity equation should be appropriate, and OpenGL, that means open digital library, is used to support the files, and we have to increase our tricky condition to solve all the problems in Bayes surface. These are all the analysis we have done after that, after the completion of Bayes surface and Bayes curve and Bayes plane analysis. These are all the basic things about the Bayes curve and its surface. Remaining we will see in the next class. Thank you.